Right guys, let's have a go at this one. What I'll do with this one, we've got to differentiate, find the turning points. We're going to try and sketch the curve as well, and this will be slightly new I think on this one. So let's put, first of all, to do the y dx, let's put everything on ground level. So let's flip the x squared up. So x minus, flip that up to be with the 6, and you have to flip the index to -2, don't you? Now let's get the gradient, the y dx, the derivative. X goes to 1, -2 minus is plus, 6 2s are 12, x to the 1 less is -3. Then we can also write that in the alternative form, so let's put it there now, 1 over 12x cubed. So whatever we want to use we can. Alright then, let that equal 0. We see that equals 0 when does that equal 0? Well, let's move the 1 over, is equal to -1, and then move the x cubed up. So I'm going to read from right to left as I do that. Minus x cubed is 12, so then times by minus on both sides. X cubed is -12, isn't it? Cube root. To undo a cube, you cube root. So I'm not going to say too much about that here because the time doesn't permit me to. But I can take power third. That's the rule x to the a, power b is equal to x to the ab. So to undo a cube, you take power third, because 3 times a third is 1. You only get x to the 1 then. So cube root to undo a cube. Cube root both sides, because you have to do the same both sides. Tap it in the calculator then. -12. So cancel that lot. We've got brackets. Oops. We got bracket -12 bracket power, and it was 1/3, wasn't it? So I'll put it as a fraction. 1 over 3 power third of -12 -2.29, because the 9 rounds the 8 up to a 9. -2.29 -2.29. There we are. That's our x value. That's our input value. What's our output value then? This is the easy one to use, isn't it? When we're working out the value. So at x equals -2.29 then. Y equals, well, it's going to be x minus 6 over x squared. So I'm just going to write it down again. So it's -2.29 is the x, minus 6 over -2.29 squared, yeah? Tap that in the calculator then. -2.29. Well, it's standing on ground level, so we can just write that without a bracket. Then it's going to be -6 times, and then I'm going to put a bracket just to be safe, and then it's minus. So I'm going to put another bracket. So it's divide anyway, isn't it? It's divide. Now I'm going to put bracket, and I'm going to put another bracket, right? Just to so everyone's on board with this. 2.29 bracket, and I'm going to square that. Then I'm going to close the second bracket. So can you see that? You'll work out that first, which is -2.29 squared, and then you'll have 6 divided by the outer bracket there, which is what we wanted. So it's -2.29 minus 6 over that number equals -3.43. Agreed? So let's put that in. -3.43. So there's our input output. So let's do a little sketch of that then, because we're going to do a sketch of this in a minute. There's x, there's the input row, there's the output. We found a turning point that happens when the input is -2.29 and the output is -3.43. So the height is negative, so it's down below the 0, and there's our coordinate. Now at the moment we don't know if it's a min or a max, so I can put it like that. Okay, so next thing then, we need the second derivative to see if it's a min or max. d2y by dx squared then equals, so we'll use this line here because it's easy to deal with, yeah? So the 1 goes to 0, -36, 3 12s are 36, so it's a minus 36, because a plus times a minus is a minus, x to the -4, which equals -36 over x to the 4. We can write it like that. Now, the thing to notice about this is something to the 4 is always positive. So irrespective of what value of x I inputted, this would be positive, and the top is negative over positive, so that's always going to be less than, for non-zero x, it's going to be less than 0, isn't it? And we can put in x and you can work out the value, but we know it's negative. So straight away we can say so a max. There we go. So we know it's a maximum. So there's the curve. Now the trouble is we need another couple of tools in the tool bag to be able to draw this thing, don't we? Because all we've got from this curve at the moment is this. We don't know what on earth happens here. So I'm just going to do a quick little resume of curve sketching, although I do it in a will be doing it in a different section. Here, look at this. X minus 6 over x squared. For large x, right, large values of x, x squared, 6 over x squared will be a really small number. And this will be the dominant term for large positive x, won't it? Like if you put 100 in, 100 squared is a really big number. 6 over 100 squared is really, really small. So the dominant term is this, and that would be 100 squared, wouldn't it, minus a smidge. So it's just under that line. That line is the line y equals x. So let's put it in. So for large x, it's just a smidge under. So there we are. They tend towards closer and closer and closer to that line. For large negative x then, again, negative 100 minus 100 squared would be a large positive number. Minus 6 over 100 minus 100 squared would be negative, wouldn't it? So it'd be just done, and this would be minus 100. So it would be just below this line here, because this would be the dominant term. So again, you'd have that, and it would come up like that, wouldn't it? Just under that line, but get closer and closer and closer to it, because you're only taking smidges away from that line. So can you see what happens? Now the other thing that varies is when x gets close to 0, because that's when this shoots off to big values. Like if I put 0.1 in here, say, 0.1 squared is 0.01, 6 over 0.01 is 600. So you've got 0.1 take away 600. It's going to be massively down here, isn't it? Yeah? So it's going to shoot off down to minus infinity as x gets close to 0. On the negative side, if I put minus 0.1 in, that would be minus 0.1. This would be minus 0.1 squared, which would be 0.01. 6 over 0.01 would be 600, which is dominant, and minus 600. So again, it would shoot off down there. For just on the negative side, it will shoot off to infinity, down negative infinity. So can you see what happens? It doesn't turn anywhere else, does it? So it's bound to just go down like that, sort of thing, and then come up, come round to its only maximum, and then tend off down there. So that's a little rough sketch. Oops, I don't. Oh, I've gone a little bit loopy here, haven't I, with this thing? Let's just get that back on track, and then I can maybe draw the thing properly. I'm going to go up to the maximum and then shoot off down there. So sorry about the poor quality of the sketch. The priority in this section is not to do a sketch anyway, is it really? It's to find turning points. And I'll be doing sketches in another section, yeah? I think for the sake of completeness, I can just mention it briefly, which I've done here. Whoops, so that's pretty poor. Anyway, that's the characteristic shape, of the curve, yeah? And apologies for the poor quality of the sketch. Okay, so let's go on to the next one now. Well done, good. So we found the turning point anyway. That was the main thrust of this playlist here.